All right. I'll start with the introductions. I'll start with what's on the agenda today. Start with the introductions of our esteemed guest today, and then we'll move on to what's the content for today's special day. We have our day, National Space Day, that marks a significant event in our historical ISRO's soft landing missions. So we'll start with what we have done for a bunch of stuff like that. Okay. So let me introduce myself. I am Yashraj Singh, one of the founding members of Propagation. We do a bunch of stuff. We do programs, trainings, internships, and projects. We specialize in making you very aware about space sciences and AI. A bunch of our stuff is very, very unique. You won't find it anywhere else. So that's what we do. That's our mode. We have very specialized bunch of individuals in our team. So that's what we do. Now for today's agenda, we have our very esteemed guest, Mr. Sibsankar Patil, who has told me not to call him sir, but we respect him very much. So I'll just explain to you who he is and why he's here today. He is the founding and executive director of Live 2 and Beyond Foundation. He has done a bunch of work educating a bunch of individuals in space science and as biology. And I mean, biology in this field of astrology, astrobiology in the sense. He has contributed to a bunch of projects. He has done a lot of freelance work. He has educated so many individuals that he is the one who is fit for today's space science event. The significance of today's event stems from us marking a National Space Day where Chandrayaan 3 did a soft landing on south side of the moon. So a few instructions for you before we start. If you have any questions, do type it in the chat. You can just type in the chat. Sir will take it at the end. And we'll also take audio questions. So you can do it there as well. Now, if you stick to the end, we'll have a very special announcement for you because we are launching a winter school, which will be very beneficial for you if you're very interested in astrobiology and astrophysics. All right. I'll let Sir begin now. Enough from me. Now I'll let Mr. Sibsankar Patil begin. Thank you, sir. You can go ahead.
Thank you, Yash. I'll just take a moment to share my screen. First of all, hello everyone and happy National Space Day. While I share my screen, a few things I just want to share with you all. Just a second.
I think somebody is not muted his mic. So you can start here.
Yes. Is my screen visible properly?
Yeah. Yes, sir.
Before I start, I just want to make a few things clear for all. Is that the poster seeing which you all have joined today says it's an interactive session. So it's not me blabbering a lot about the missions and what the ambitions of the Indian space program are. I would also expect some of you to write something in the chat, as well as from time to time we can also switch on the audio. Maybe I can ask you all to answer certain things. And at the end, we can also take up some wonderful questions. So today is a National Space Day, and today we'll be discussing more about the Indian lunar exploration journey since the beginning of this century. And also the ambitions. Like we know, the Indian space program has become popular a lot globally in the recent years because of one very important mission we know as the Chandrayaan 3. Before that, India has done a lot of wonderful work in the domain of lunar science exploration or like Martian exploration and all. But then still, Chandrayaan 3 remains as a classic example that kind of sought the attention of the entire world towards India, which used the modest of resources to reach the moon and at a place where no one have ever reached. So without further ado, I would just like to begin um, today's discussion. Again, Happy National Space Day. This year we have the theme from the Indian government and ISRO, that is Aryabhatta to Gaganyaan, ancient wisdom to infinite possibilities. Here, Aryabhatta, obviously, you can consider the great mathematician Aryabhatta or the Aryabhatta satellite, the first satellite that India launched from here. It's 50 years since like Aryabhatta satellite was launched back in 1975, and it's no longer in orbit, obviously. And the Gaganyaan mission, like recently, ISRO chairman Dr. V. Narayanan was mentioning that by the end of this year, I think so in December, non-human space flight consisting of the Vyomitra, the female humanoid robot on it, and all. So a lot of possibilities exist in the upcoming days for the Indian space program. And obviously, not to forget, thanks to Propagation team and to SA Citizen Science for this opportunity to get an audience like you all to come together and discuss this thing on this day. And just a bit about myself. I'm Sibsankar Palit, not Sibsankar Patil, not from Gujarat, from West Bengal. And I am a space entrepreneur. I run the Life to and Beyond Foundation, which is a non-profit organization, space organization, which works with space biology and astrobiology. And alongside, we also work with space law and economics, and obviously space education. So these are some of the broader fields that we work in. And myself, I work in the field of space chemistry, essentially with regard to space biology, like certain technologies and biosignature detection and cataloging with regard to astrobiology. So these are some of my specific research works. And obviously, I am a science communicator. And today I come here in front of you all to discuss this as a science communicator rather than a lunar science expert. So there are certain advantages and there are certain disadvantages when it comes to becoming a science communicator. For a science communicator, one may or may not be an expert in a particular field. Let's say for the lunar science, I'm not an expert. But at the same time, being a science communicator, it increases my spectra, or let's say my connection to a broader set of people with whom I have interacted to date, and let's say like exchange knowledge, which I'm here to share with you all and discuss with you all in a less jargon format. So I represent a number of organizations, but mainly Life to and Beyond Foundation. Alongside that, I'm also a member and on the board of directors of certain other global space organizations, some of which like the ACS Worldwide, which is an observer status organization of the UN COPUS, like SGAC and Moon Relay Association and all. So that's a brief about myself. Now, today's session is not about myself. It's about the Indian space program. So when it comes to the Indian space program, one person often whose work we do not acknowledge much and whose vision we do not remember much is obviously Dr. Vikram Ambalal Sarabhai, the man, and along with his team, who envisioned a space program for a country like India, and who was not just a space scientist, okay, to be more apt. He was a physics person, but he went on to do a ton of things. Like, let's say, he went on to found the Vikram Sarabhai Community Science Center, like a science museum kind of thing in Gujarat, to even like setting up the scientific organization for a textile industry. Okay, so that we can have high quality textiles made in India. Okay, today we hear a lot about Make in India and all. This didn't start anew. This started long back from Vikram Sarabhai, or let's say even before. Okay, and then he was the first person who started the IIMs, let's say the IIM Ahmedabad, and we know it led to many other IIMs. He basically wanted to foster the very spirit of project management, the importance of project management within the country and its training. And so to train such individuals um, he created the IIMs. Unfortunately, in today's greater trend, we see IIM graduates going to high-paying jobs outside India. But then that was not the vision with which IIMs was found, unfortunately. And obviously, he went on to lead the Atomic Energy Commission after the death of his very dear friend and peer group person, Homi Bhabha. So he also led the nuclear program and found a number of institutions. And obviously, he kind of encouraged younger people like you and me that time, let's say Abdul Kalam, or even there are other examples who went on to work in ISRO or other organizations beyond ISRO, means fostering that project development, project management spirit and using science for the betterment of society. Okay. And these are some of the organizations you can see he found, like the PRL, ISRO, the Space Application Center in Ahmedabad, and then VECC, the Variable Electron Cyclotron Center in Kolkata, and then also Department of Atomic Energy, which he led. And obviously, the most important is ISRO. That is the one for which he is mostly known for. And he conducted a lot of experiments. One of the most important one being the TV broadcast in villages nearby Delhi. It's a very big project using NASA satellite. It is to date the biggest educational experiment done using space technology. So impacting so many villages, like the Doordarshan that we know, that was kind of broadcasted that time using satellite technology in the remotest parts of India. So that was done by ISRO under the leadership of Dr. Vikram Sarabhai when he was alive. But then, as they say, a leader is not one who does everything during his lifetime, but then he creates an environment such that when he is not there or she is not there or they are not there, the organization can go on, the good work can go on. And that is what Vikram Sarabhai stands for. So Vikram Sarabhai was a multifaceted individual at Life to and Beyond Foundation. In his honor, we started the Outreach Sarabhai initiative 3 years back, which has impacted a lot through online or even in the remotest parts like in Chhattisgarh or West Bengal or Rajasthan and UP and other parts of India. So in his honor as well today, obviously, when we are talking about the National Space Day, his story is obviously meaningful to discuss. Okay. Now, that's about Vikram Sarabhai. But then Sarabhai, when he started Indian space program, he didn't envision like the moon missions or human spaceflight missions. He started the Indian space program for the application of the citizens of India. Okay, predominantly. But then today we have been to the moon, we have landed on the moon, we have been to Mars orbit, and now we are also
Oh, sir, you are muted, sir. So just unmute yourself. You are muted, sir. Yeah, okay, sir. Just try now.
Yes, sure. As I was discussing, that for the Chandrayaan series, it didn't start something when Vikram Sarabhai was there, but he envisioned for these at that point in time when INCOSPAR, like the first initial form of ISRO, started in 1962, 1963, and then it officially got recognized in 1969 on 15th of August as ISRO. So that time it was focused more on civilian application or like for the betterment of the citizens of the country, or the Republic of India. But now we are going to the moon, we have been to Mars and human spaceflight missions. and multiple other things like Venus. Will be going to Venus soon, and like even collaborative missions will come up. So a lot of things to discuss. But then today is special with regard to the Chandrayaan series. Now, why the moon? Like, obviously, there are multiple reasons to go to the moon, right? And um, some of the most important things when we come to the moon missions, like the scientific motivation. Some of them are
Some of
listed
the
here. Most important things when we come to the moon missions, like the scientific motivation. Some of them are listed here, some of them are not. Like some of them that you know, obviously, is it's an airless body, and means it doesn't have an atmosphere. So unlike our Earth, like if we have an atmosphere, we are lucky enough, but at the same time unlucky enough in the sense that it doesn't allow certain wavelengths of electromagnetic radiation, or let's say the different kinds of waves to pass through it. It gets reflected, or let's say some gets trapped within the Earth's atmosphere. So light itself is a light, or let's say most importantly, electromagnetic radiation helps us understand things, helps us better analyze things without even touching that particular thing or coming in contact with a particular thing. So remotely we can collect light signatures or electromagnetic signatures and understand what that thing is made up of, be it its physical or chemical or biological features. Okay, so that is what we call remote sensing. So when it comes to the moon, there's no atmosphere, so it becomes easier that even like with a satellite or an orbiter around the moon, we can study a lot of things. And it doesn't have any magnetic field. So unlike our Earth, which kind of reflects back, or not reflects back, some part is reflected and some part is kind of like forms the aurora borealis or aurora australis, as we know, on the two poles of our Earth, when the solar flares consisting of highly ionized particles collide with the magnetic field of Earth. But then on moon there is none. So what happens? The solar flares, like the ionized particles are there in the exosphere of the moon, or the like the atmosphere of the moon, and then um, also like the helium-3, we know helium, the element, and its isotope with mass number 3, it gets deposited on the lunar surface. This is called lunar regolith. Okay, like a collection of like layer after layer of helium-3 isotope material from the solar flares. So what happens? Helium-3 is a radioactive um, element, we know, and it can fuse together to form to give nuclear energy. And in fusion, we know there's greater amount of energy. So in future, like if we mine this helium-3 a lot from the moon, we can also set up nuclear power plants or nuclear reactors up there on the moon to generate nuclear energy out of them. And obviously, like as we move to the other planet, we expand, because earlier we humans, as they say, we were all uh, members of Africa. Like means our ancestors spread across the world from Africa to different continents. Earlier we were there on one continent, now we are multi-continental. And now we are on one planet. We aim to become multi-planetary, or let's say multi-celestial species, so that we are not only there on Earth, but also on the moon, Mars, and other planets or moons, right? So these are the three major reasons. One is to study the moon, which gives us an understanding, so a scientific or a fundamental understanding of what the moon is. Even like, as you all may know a bit, that the moon was actually formed as per the giant impact theory, that when a Mars-like big object at a point in history, Earth's history, hit Earth, a part of Earth only got separated as moon. So like on Earth we have atmosphere, but on Moon we do not. So there is no weathering or like geological activities much on the Moon. So let's say the Moon has been same since then. Let's say 4.4 billion years back, something like that. So if we study the Moon, we can also understand the early form of Earth. Okay, that's the first reason. Second, obviously helium-3 deposits, and third is expansion of humanity beyond Earth. So these are the three main reasons, and to date scientists have like tried to understand the elemental composition and the mineralogy and the geology and exospheric studies and the particles present in the outer environment of our Moon. So these are enough actually to go to the Moon, means reasons enough to go to the Moon. Okay, and this is beyond just Indian missions. It is applicable for American, Russian, Chinese, and other missions as well. Now, Chandrayaan series in brief, if I say, Chandrayaan started back in 2008, like Chandrayaan 1, and then Chandrayaan 2, 2019, and then Chandrayaan 3, 2023. And we are standing 2 years after that, 2025. So the envisioning of Chandrayaan started in 2001, 2, 3, that time. Okay, and then eventually the first mission, the orbiter mission, like a satellite kind of thing, which would move around the Moon, went in 2008. And then there was a hard landing probe. Like, let's say if I take any object and throw it like at a very fast speed, and it impacts hard on the surface of any land, then that's a hard landing. So 2008 mission consisted of these two major things. One is the satellite of the orbiter around the Moon and the hard landing part. So that point where this hard landing took place, we call it as the Jawahar point, after our first Prime Minister, Jawaharlal Nehru. And then Chandrayaan 2. Chandrayaan 2 went to the Moon. It consisted of three things: the orbiter, and then the lander named Vikram, and the Pragyan rover, or the like robotic car that came out of the Vikram lander. So 2019 it went to the Moon. The orbiter was successful for deployment in orbit, but then the lander and the Pragyan rover unfortunately crashed at a point we now know as the Tiranga point after the Chandrayaan 3. So Chandrayaan 2 was about all of this, and Chandrayaan 3, which was kind of a retake of the Chandrayaan 2 mission that didn't succeed, the part of Chandrayaan 2 that didn't succeed, which included the Vikram lander soft landing near the lunar south pole, and obviously the Pragyan rover, the car coming out of the Vikram lander. It included these two parts. And obviously the successful part of Chandrayaan 2, that is the orbiter part, was also used for proper landing of Chandrayaan 3. So it's not that Chandrayaan 2 was a failure, it was an in-part failure. Okay, and science is all about, let's say, hit and like try and fail. Okay, and then you learn again and you try again, right? So it is a journey of perseverance. Just to keep it in one line as it is described here, these three missions, it was to understand Moon better in a chemical manner and mineralogically, and its geological mapping, like to better geologically map the Moon. These three missions altogether contributed in that way. Okay, and each of these missions had their own set of payloads. I'm not going to discuss all of that because each one would take a lecture in itself. Okay, and the science from Chandrayaan 1 to 2, like you can see, I'm not going into much detail here. These are the payloads of Chandrayaan 1. These are the payloads of Chandrayaan 2. These are the specifications of Chandrayaan 1's payloads, and these are improved specifications of Chandrayaan 2's payloads. So these are the enhanced science. Like with each mission, they have enhanced the scientific questions and to better understand the chemical and geological mapping and the mineralogical composition of our Moon. Okay, one of the key things to understand here is Chandrayaan 1 was responsible, like a payload on the Chandrayaan-1, basically one of NASA's payloads, was responsible for detection of these hydroxyl like molecules, or you can say a detection of hydroxyl ions and water, and like in the form of ice. The signature of water was found in the lunar south pole. Okay, and later on, through remote mapping in Chandrayaan 2's orbiter also, further, let's say, kind of validated it, mentioning that these water or these ice were present in the dark craters, kind of like dark regions in the lunar south pole. And that is why, like, that is one of the major reasons why we chose the lunar south pole as a point of landing. Okay, like near the lunar south pole, not exactly lunar south pole, near the lunar south pole. Okay. Now, same goes for Chandrayaan 2 to Chandrayaan 3. Lot of, let's say, enhancements were done in terms of the payloads. Okay. From studying plasma to studying elemental composition to understanding like temperature, like how temperature changes in the lunar soil. All of these components were added. Okay. You can find all of these details on ISRO's website. I'm not going to discuss all of this because these are not important in context of this entire talk. What's more important is what Chandrayaan 2's failure, the part that failed, could offer for Chandrayaan 3 such that it would become a sure shot success. Okay. So there were improvements done in software, in sensors, in propulsion systems, and then like they also reworked the touchdown limits and also improved the mission plan to altogether. And then improvements in the NGC, then exhaustive simulations and ground tests were done. And also in the propulsion module, like the one during the soft landing, those propulsion modules were also improved. And then the hardware was also like made more redundant in terms of making the Chandrayaan 3 soft landing an absolute success. Okay. In fact, if you have followed the Chandrayaan 3, like, or the Chandrayaan series for long, like you must have known or understood at least to some extent that when Chandrayaan 2 happened, like some level of confusion still was there. But on the Chandrayaan 3, like that evening when Chandrayaan 3 landed, it meant altogether that it was going to be a success. So like a lot of improvements were made in terms of like software, hardware, and propulsion modules and so on, that led to the success of Chandrayaan 3 eventually on 23rd of August in 2023. Now, why land near the lunar south pole, a part of which I have discussed already, but then there are a few more details to it. This map you all can see, I believe, right? So I would just like to ask our audience some questions, like maybe in the chat you all can share. How many countries have made like successful soft landing on the moon to date? Like, can you name those countries? Anyone? Like, you can type in the chat maybe. I'll just take 2 minutes here to get some inputs from you all.
Maybe yes, for India, yes. It's Russia and
Yes.
USA and Australia.
Including India, we can say that there are 5 countries
India,
like Russia, Soviet Union, US, China, Japan, and if
Right.
India we can take.
Yes.
Right. And
China,
obviously,
Japan, US,
we
and the
know
Soviet
that
Union.
like America did, and Soviet
Yes,
Union did,
yes.
and
Yes.
Russia also did, obviously, and China did, and India did. These are the
Japan
4 first nations. Japan, right? And there are a few more.
and India at last.
Obviously, I did mention India.
India,
Like,
yes.
five of them are already there. USA, Soviet Union, or Russia, China, India, and Japan. And then any more?
Australian, maybe.
Not
No, I
Australia.
don't think so.
No.
No, not Australia. Any other?
I don't
Yes,
think so.
Italy. Yes.
Italy.
Yes. Italy has not soft landed, I suppose. I suppose it's a like orbiter mission. I think so. Hard landing, Italy has
Israel,
done. Yes, Italy,
Israel with
Israel,
any,
right? Israel has done hard landing,
yeah, I've studied it earlier that with USA it has tried.
right?
Yes.
There are a
NASA.
lot of like there are a lot of countries like beyond Japan, like the till Japan, like USA, Russia, or Soviet Union, or let's be more precise here. Let's say it as Soviet Union because Russia has not soft landed properly. Soviet Union, when it was there, that has soft landed. Okay, so Russia, USA, Soviet Union, China, India, and Japan. These are the 5 nations that have soft landed on the moon. But then there are multiple examples like Israel and also Russia, like hard landing, because there was one mission which also went along with the Indian Chandrayaan 3, which crashed on the moon. And then ESA also tried, but then unfortunately that was a hard landing. And Luxembourg, obviously. South Korea also tried, right? Somebody said South Korea. And Italy also did one hard landing, if I'm not wrong. UAE also tried to land to make a soft landing, but it was a hard landing. It was a private mission actually, and yeah, these are the major hard landings. I'm not much sure about Italy. I need to check that. But then for ESA and Israel and Luxembourg and UAE, they did land like means a hard probe, like a hard landing probe on the moon. So okay, if Italy did it, so for sure Italy, we can also consider Italy for sure. So there are number of countries that are trying now, and now there are private missions as well. You have heard, obviously, right? So the Blue Ghost lunar lander, which I suppose at the beginning of this year landed on the moon. So there are multiple such attempts that are being made by multiple stakeholders, not just government, but also private endeavors. So this goes on to show that how much important lunar exploration is becoming. Right. Now for the lunar South Pole, choosing lunar South Pole 69.3 degrees south and 32.3 degrees east. That's the exact coordinates for Chandrayaan 3. Some of the major reasons, as I mentioned, that in the initial missions like Chandrayaan 1, higher latitudes were unexplored, like not only in Chandrayaan 1, by other missions as well. Okay. If you see this map properly, most of the landings, like for China or USA or Soviet Union, they are at the center, near to the equator, right? But not very near to the poles. Only China tried one, like Chang'e 3, and then Chandrayaan 3 here. Please note that this particular map of the moon is still India's soft landing, and beyond that, like Japan and other missions, they are not included here. Okay. And obviously the unique conditions, like the sun shines at grazing angle. Basically, there's lesser energy that is that hits the lunar surface in certain regions, and obviously the solar wind ions and electrons to understand these ionospheric studies as well. And most importantly, the topography, the geological mapping of the moon became very important. So that's the scientific motivation behind choosing the lunar South Pole, or near, like a point near the lunar South Pole, as a landing point. Okay. And for technological reasons, conditions on global slope, in terms of the conditions of size of boulders and craters, and also the shadow analysis, the darker regions. In the darker regions, as I mentioned, like there are certain dark regions in the lunar South Pole where there has been traces of water or water ice that has been found. And then like power generation and communication with the Earth. These kinds of technological demonstrations. For these technological demonstration, the lunar South Pole was considered as a good exploration point, from an exploration point of view, to explore. So for India, that's turned out to be the case, something that has not been done by others. And that is what science is all about, right? Science is not like copying and paste, right? Science is about exploring what others, like building on others' work, and then like expanding, or let's say extending the frontiers of human knowledge, right? So that was the major reason for choosing these coordinates. Now let's come to just a recap of Chandrayaan 3. Chandrayaan 3 was launched like on this GSLV Mark 3, now called the LVM-3 launch vehicle, on July 14, 2023. From Sriharikota, we know the launching site for India. And like India follows a very, very cost-effective approach and a time-intensive approach in terms of sending these like spacecrafts to other celestial bodies, which takes round and round, like basically using gravity like of the celestial body, and then speeding up at particular points so as to increase the size of orbit, and eventually like kind of literally throw it in a trajectory such that it moves towards the other or the target celestial body. And when it comes under the gravitational influence of that celestial body, again kind of slowing down or kind of reducing the orbit and eventually landing on the target celestial body. So this was considered for our like Martian orbiter mission, the MOM, back in 2014, and also like for these Chandrayaan missions as well. Okay. And this proved to be very, very cost effective, yet time consuming, to be more apt. Now, one interesting thing, like we have often heard about space race, but then Chandrayaan 3's timeline, that was a very unique timeline in the sense that that time we could actually witness a live space race. How? On August, like actually the Chandrayaan 3 was launched on July 14 on the launch vehicle, right? And it was tentative to land on the moon like around 22nd of August or 23rd of August. Okay. And then there was another mission, Luna 25, from Russia, which was launched on August 11. It would hardly take a few days, like a week's time, to reach the moon, because just in one orbit, it was going to send the spacecraft to the lunar orbit and then eventually landing it near the lunar south pole. So that was not cost effective though, unlike India's one, but it was very fast because it used a lot of fuel and energy to send or propel the spacecraft towards the lunar orbit. So for Luna 25, which was a moon mission by Russia long after Soviet Union's time, okay, like it was perhaps one of the first missions after Soviet Union stopped like sending missions to the moon. And India, on the other hand, is taking its second attempt to like soft land near the lunar south pole after a part failure of Chandrayaan 2. So it's a like race like situation where one has started faster, but then is tentatively going to reach late. And on the other hand, one has started late, but is tentatively going to reach faster. Now, who is going to win the race? Right? Who is going to land near the lunar south pole? Right? It was going to make history. Unfortunately, the Luna 25 spacecraft crashed and it lost connection with the station back there in Russia and other parts of the world. So unfortunately, Roscosmos's mission Luna 25 couldn't make it to the moon, which is equally sad as the success, as like we feel happy with the success of Chandrayaan 3. Why? Because it's not like a space race, however competitive or however country versus country it may be, but then space is not like any country's property, right? It's a human endeavor, or a space exploration is a human endeavor, right? So whoever wins, it's not just a win for that nation, it's a win for humanity as a whole, right? Chandrayaan 3's data will be used by America, Russia, China, and other countries. Same goes for like other missions as well. So it was sad that Luna 2025 couldn't make it, but at the same time, Chandrayaan 3, like in its slow and steady process, ultimately won the race when on 23rd of August in the evening, as per Indian Standard Time, it soft landed near the lunar South Pole. Here's the landing graph you can see, and it took a few more seconds actually. I think so. It was around 6:30 in the Indian Standard Time in the evening that this landing happened, and finally, India on 23rd of August 2023, that is exactly 2 years from today, at 18:04 IST, as I was mentioning, like around 6 or 6:30 p.m. Indian Standard Time, it achieved the soft landing on the moon. It became the first country, India became the first country to have achieved soft landing in higher lunar latitudes, and the fourth country ever to have successfully soft landed on the moon or the lunar surface. So with that, India made history. But then apart from all of this history and all, like there will be more such histories created by India and other nations. But on a personal being, like to me, that day I still remember in the sense that how that day felt like. Like I essentially stay in Kolkata, and like some of you, those who are from India, may know very well the city of Joy, Kolkata in West Bengal. It's a very vibrant city. So like there's a science city, which is a very big science center here in Kolkata. So that day in the morning, I visited Science City for some activities and like some outreach activities. But then before the live broadcast of this mission in the evening, I had to come back for some reason. So I was on a public transport from Science City to nearby local railway station, and like around the time of 6:04 IST, I was on a bus on a public transport, and I could see live on YouTube that the soft landing was taking place on ISRO's YouTube channel. And I distinctly remember that, okay, I'm a space enthusiast, it's good. But then like alongside myself, there was sitting like some bank employees, or let's say daily wage worker, or let's say some, even the conductor, let's say the bus conductor. Everyone were kind of like, they were either on mobile watching the live like soft landing, or let's say they were discussing, or like it was a total kind of like the citizens of the country felt like they are a part of this mission, or a part of it was there, or a part of them was there in the mission. Okay, and then I got on a local like train to move to a nearby place. So when I got on the train, I could see a daily wage worker explaining to another daily wage worker that how a proud moment it is for a country like India to reach the moon. And he was explaining that that India is the first country to like land near the lunar South Pole. I was getting calls from my family that we have landed, though I knew that, but still like they have nothing to do with space. But then still they remember that their son, or like I'm associated with the space work and all, and they were quite happy about it. Okay, so then I moved to a place where one of our provisional offices is in Barashat. So there, when I was buying something at the grocery store, the grocery owner was also discussing about Chandrayaan 3 with some of the people coming to buy some grocery. So what I'm trying to say is, it was as if the whole country was rejoicing like on this endeavor. And this is not at all a kind of exaggeration, but a real-time experience what I've felt. And then on social media, you will find tons and tons of videos of, let's say, people on stadiums. Let's say in Kolkata, we have the metro facility where they have launched the like special Chandrayaan 3 like tokens. And then in stadiums and all, let's say when there's a football match, or like FIFA, or let's say Cricket World Cup, when a team wins, as people rejoice, same was that day's story across India and across the globe as well in some parts. So that's what that day felt like to me. This is not something that's like recorded somewhere, or this cannot be cited in scientific literature, but something that I wanted to share with you all. And there lies the success of the National Space Day. There was no space day or something before this 23rd of August as such officially declared. Okay, there was National Science Day, but then there was no National Space Day for India. But then Chandrayaan 3, beyond the scientific objective, or let's say this lunar exploration and whatnot, it connected people, it connected hearts. Like even like if you are in India, or you visit like India, if you are from other part of the globe joining us today, you will, if you visit India, you will find Chandrayaan 3's let's say pictures or murals on the walls, okay, in local streets, or let's say behind a bus, or let's say in rickshaw, or like or in common people's discussion. Like they may not even know the name of ISRO, but they will know the name of Chandrayaan 3. Okay, so there lies the success of this mission, that it connected people like with a greater scientific mission. Unfortunately, science, however important it is in our human life, has not been able to connect people like arts and other fields. But then when a scientific mission, a space mission, connects humans, connects hearts to hearts, connects people, there lies the success of the mission beyond the scientific objective of the mission, right? So that's what Chandrayaan 3 stands for, like to me and to many more. Okay. So that's Chandrayaan 3, a journey. And during its 2 weeks of time, when it got the sunlight from the and the solar panels worked, like it did a lot of activities, let's say from some experimentation on temperature studies to, let's say, the lunar, the Pragyan rover. As you can see this picture, if you see this picture, the Pragyan rover coming out of the Pragyan rover coming out of the Vikram lander. Okay, and then this is the pathway that it traced. You can see the Shiv Shakti point. This is a point where Vikram lander soft landed. That's the name of the point. And it traversed various pathways covering all like more or less more than 100 meters altogether. Okay, to and fro. And then there was also some hopping experiments, like the lunar lander hopped, so that it could be, these kinds of studies can be used for betterment of future missions as well. So all kinds of studies were done. Some of the very important like results from these missions, like initial observations, and then there are published literature you can check out, and there are more in detail studies that are being done till date. Okay, so there was the first ever detection of sulfur, the element sulfur, on the lunar regolith, and also trace constituents of elements like carbon, nitrogen, phosphorus, titanium, manganese, and chromium and nickel. Like they quantified, they kind of measured how much of this particular composition of like elemental composition exists in the lunar sample near that region where they landed. Okay. And there were also some few events of ground vibrations of the lunar surface that were recorded, as you can see here in this red color marked graph of vibrations. There were also first ever characterization, like kind of characterization of near surface lunar plasma at higher lunar latitudes. Like basically the plasma that came from the solar flares and all, which kind of got deposited, or let's say were there near to the surface of the moon, they were studied in much more details in the lunar south pole, okay, in extreme latitudes basically. And like one of the initial observations that this mission reported, which I personally like was quite astonished seeing, is this one, the second one. First ever temperature profiling of the lunar regolith, okay, like they kind of measured the temperature up to 10 centimeters of depth. Please note, it's 10 centimeter. If you just imagine how small 10 centimeter is, like it's not like a lot, right? It's just, let's say, this much of my hand, as you can see. So it's a very small depth, and results show the good thermal insulating properties of lunar soil. It may not be explained well in this sentence, but it can be explained through this particular graph. If you all know, like I'm hopeful that you all know how to analyze, or like a basic understanding of graphs and what understanding it makes. If you see on the y-axis, there's the depth, like 20 millimeters of height, and then 0 means that is basically the surface of the moon, and then minus 20 means 20 millimeters in depth, minus 40 millimeters in depth, 60 millimeters, 80 millimeters. Okay, so what you can see here is that at around this let's say a bit more like above the surface, we are getting the temperatures like near to, let's say, this 10 degree Celsius, right? And as we go down, it's not very deep enough, just few millimeters. Okay, 80 millimeters is not that deep, right? Anywhere, or like it's not a great length. So, excuse me, this 80 millimeter of depth showed this like drastic fall of temperature. Like with this, like within this much of depth, there is drastic change of temperature. Okay, like the temperature dropped drastically, where it went on to near 0 degree Celsius. So that is what kind of was more astonishing to me, that at like few millimeters of depth, the temperature is dropping such drastically. And what does this mean? It means that the exchange of temperature or exchange of heat in and out of the surface is very slow. So let's say something that is cold is not able to absorb more heat from outside such that it would become near to the same temperature as outside, or the surface temperature. So that proves like the insulating capacity of the lunar soil, at least in the lunar South Pole. So these are some of the interesting scientific results that this Chandrayaan-3 mission has received. And that is what this mission counts for at its core, that what scientifically this mission tried to achieve. Okay, this mission obviously cannot bring food to your plate or my plate, or let's say light to the villages where there's no light, or let's say some other social, let's say, cause. But then something what it can do, it can extend the boundary of human knowledge that other missions or other projects cannot, right? And it is this extension of human knowledge that has brought humanity to a date where you and I can sit like in remote places anywhere in the world and join on a Google Meet and like discuss this session or discuss this particular topic. So human exploration, like to explore is to be human after all, right? So that's about Chandrayaan-3. All good, all fine, great. But now, some of you may or may not know, the Chandrayaan-3 team, ISRO's Chandrayaan-3 team received the 2024 IAF World Space Award, which is basically the Nobel Prize for space work. Okay, obviously the Nobel Foundation doesn't provide for Nobel Prize for space studies. Like associated fundamental science studies in physics and chemistry can be awarded, but not for space. But then there's the International Astronautical Federation, which also hosts the IAC, the International Astronautical Congress. This year it's happening in Sydney. Last year it happened in Italy. So in 2024, in October, the ISRO Chandrayaan-3 team as a whole was awarded this particular prestigious award. Many other space missions and individuals have had the honor to receive this award, and it's really prestigious enough because you get a recognition on a world level. Like amongst all the space missions that have happened in 2024 or 2023, they chose Chandrayaan-3 to be worthy enough to win this prestigious award and get a recognition and edge over other space agencies, right? So that is quite important and worth noting. That's Chandrayaan-3's team with men, women, and people working together hand in hand to make this possible. Obviously, I cannot name one person or two people, but it's a teamwork that eventually led to the success of this mission. So, as ISRO chairperson that time, Dr. S. Somnath mentions that Chandrayaan-3 mission by Indian Space Research Organization exemplifies the synergy of scientific curiosity and cost-effective engineering, symbolizing India's commitment to excellence and the vast potential that space exploration offers humanity. Rapidly unveiling previously undiscovered facets of the moon's composition and geology, the mission stands as a global testament to innovation. Achieving a historic milestone, Chandrayaan-3 becomes the first to touch down near the lunar south pole, showcasing both aspiration and technological prowess on an international scale. This is the exact statement that was used for ISRO's Chandrayaan-3 team when they were awarded this IAF World Space Award back in 2024 October in Milan, Italy. And the famous statement made by the then ISRO chairperson, Dr. S. Somnath, to the Prime Minister of India, that India is now on the moon, right? So the story of ISRO, like if some of you know how ISRO started, it started back in 1962, taking a launch vehicle from NASA, launching it from India, from a village named Thumba, the fisherman's village. Okay, and the first office of ISRO was a small room in a church. They didn't have the funds or the infrastructure in that village that time. And then carrying rocket parts on bicycles, as you can see here in this particular photo, like carrying rocket parts on bicycles or bullock carts, and eventually this LVM-3, you can say, taking the Chandrayaan-3's spacecraft or the Vikram lander along with the Pragyan rover. This combined picture kind of adds a wholesome approach to what Indian space exploration or Indian space program has been all about. Like no roads too long, no dream too big to achieve, right? So with more than 60 years of experience and perseverance, India finally made it to the moon, and now it is making much more strides in other directions as well. Meet the Moon Man of India, Padma Shri Dr. Mailaswamy Annadurai. Often we forget the people behind the missions or programs, and Dr. Annadurai is one of them, who played a key role in the Mars orbiter mission and the Chandrayaan 1 and 2 mission. It is his he's basically the program director of all of these missions. And then Chandrayaan 3 happened. He may have retired before the Chandrayaan 3 mission, but it is not because it is because of the Chandrayaan 1 and 3 and missions like the Mars orbiter mission and its success that we eventually led to the success of Chandrayaan 3. Recently, we had the honor to receive an award, our teammates, for our space education work from himself, Dr. Annadurai, in Tamil Nadu. And that's me, you can see, at the Global Space Exploration Conference in New Delhi, which recently happened in India. That's Chandrayaan 3 scale model, and that's Chandrayaan 4. Chandrayaan 4 has not been officially declared when it is going to be launched, but we are hoping that by 2028 it should be launched. Okay, and it looks somewhat like this, the actual Chandrayaan 4 body, which is like on a scale. This model here is on a scale of 1:4, like the actual one would be 4 times greater than this one, right? And it's basically the Chandrayaan 4 integrated module, and it's a lunar sample return mission. It endeavors or kind of aims to bring back sample from the lunar south pole. Okay, and then comes Chandrayaan 5. So these part, like from Chandrayaan 4 onwards, these are ambitions, like the lunar ambitions. Like today's topic was India's moon missions and ambitions. So India's moon ambitions are like this: Chandrayaan 4, the lunar sample return mission; then Chandrayaan 5, or the lunar polar exploration mission, LUPEX, in collaboration with JAXA, the Japanese aerospace exploration agency, to kind of map out and like explore the lunar south pole in much more detail, in much more like a better analysis and in a better approach. Okay. And obviously the Gaganyaan missions, these are the 4 astronaut candidates. Obviously he's an astronaut now. Astronaut Shumanshu Shukla, astronaut candidate Balakrishnan Nair, astronaut candidate Angad Pratap, and Ajit Krishnan. He's Ajit Krishnan and he's Angad Pratap. And that's me, you can see, with the suit in front, which I'm not wearing, obviously. But then many like me, and we among you all, can get a chance in the future to be a part of the astronaut missions, be it, let's say, an aerospace engineer, or let's say as a chemist or a physicist or a biologist, or even as a common citizen. Okay, even be an artist or a space educator or science educator. You can be anything, an expert in anything, and alongside being an astronaut. Okay, so the Indian Space Program will be offering more such opportunities to scientists and science professionals and to common civilians in days to come. But then it started with these four. And going forward, India also plans the Bharatiya Antariksh Station. That's the scale model behind me of the Bharatiya Antariksh Station. And this is the graphical picture. And the first steps towards this, like the Parliament of India has sanctioned, have passed the bill for the funds for this Bharatiya Antariksh Station, BAS. And the first tests, the SpaceX, have been conducted last year, the end of last year. It was successful. By 2028, India aims to send the first module of this Bharatiya Antariksh Station. And by 2035, it aims to develop this entire set of modules for the Bharatiya Antariksh Station in a much more cost-effective way compared to the International Space Station and the Tiangong Space Station of China in orbit. That's a picture from yesterday, actually, from the Bharat Mandapam in New Delhi. That's exact model of the module that is going to be deployed, I hope so, in 2028. These are the 4 astronaut candidates in front of this module. And you can see like how big this particular module is in comparison to the sizes of the humans standing in front of them or moving in front of them. So it's quite big enough, and it's exactly similar to the first module that will be there on orbit soon. So this particular model that is there on display on the occasion of this 2 weeks of celebration of the National Space Day is an example that work is in progress and in a very rapid manner within ISRO and in collaboration with other partners globally. And ultimately, all of this, as per vision document after Chandrayaan 3's success, as provided by the Prime Minister's office, it says that by 2047, by the 100th anniversary of India's independence, we aim to send an Indian or Indians on the moon by 2047. So all of this, the lunar mission, the Chandrayaan missions that have happened or will be happening soon, along with the Gaganyaan missions and the Bharatiya Antariksh stations and other missions together, will culminate into this ultimate vision by 2047 to land Indians on the moon. And that's the ambitious part of the Indian space program when it comes to lunar ambitions. I will just take a moment to end with a few words by Vikram Sarabhai when a journalist asked him back when he started ISRO as InfoSpar, that he says that there are some who may question the relevance of space activities in a developing nation. Then he goes on to say, to us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations in the exploration of the moon or the planets or manned space flight. But we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the applications of advanced technologies to the real problems of man and society. So that was the vision of Sarabhai, though he clearly mentioned that we do not aim for the moon missions or human exploration. Today, ISRO is doing that as well. But the first priority was civilians' application of space technology to progress India from a very crucial part or crucial or hard situation after independence to a developed economy, or to becoming the third largest economy in the world today, right? So all of this was possible because of visionaries and people like Sarabhai, and this quote is very apt on this day of National Space Day. So I wish you all again a very happy National Space Day, and thanks again to Propagation and SS Citizen Science Group. That's all from my end. I hope I didn't bore you. I'm open to any questions and discussions that we can have. Thank you.
Yes, sure. This was an awesome session, by the way. I learned a lot of stuff. We'll start with the questions. People who have any questions can raise their hands and ask questions directly, or if you're shy, like the last time we had conducted a session, you can type in the chat. Right? So can take the questions from there. That's it. We have a few questions already in the chat. Like, is Chandrayaan 3 helping to know more about conditions of South Pole on Moon? Yes, of course. It's
Right.
Yeah.
Exactly. As I mentioned, I suppose this question came before I shared my slide on the results, scientific results. So as I mentioned, it helped us understand the insulating properties of lunar soil, to understanding certain vibrations and how it works on the lunar surface, and also like the elemental composition, some of them like sulfur being detected for the first time on lunar surface, and then also quantifying, like understanding how much of a particular element is present in a particular region of the moon. So from that perspective, obviously it is helping us explore the lunar south pole in a much better and in a better sound way, for sure.
Somebody asks, what new technologies has India developed specifically for its lunar missions?
Could you please pardon?
What new technologies has India developed specifically for its lunar missions?
What new technology? See, technically, every like payload is new, because none of these like scientific studies have been done before. Now, when you are talking about technology, we are talking about space technology, okay? And space technology is a very, very niche technology that no nation, at least public organizations, like to share. And for India, developing its launch vehicles, be it the solid propellants or liquid propulsion systems or cryogenic systems, it has not been an easy journey altogether. It has faced sanctions many a times, and a lot of things have happened in the past. But despite that, like decades after decades of hard work, ultimately it persisted and developed its own systems. The systems are same, but then like some work better, some are cost effective, some are, let's say, more efficient. When it comes to like Vikas engine, which is the liquid propulsion system for India, it is far better than other engines that other parts of the world uses. So these are some of the niche technologies that India have developed indigenously, and like didn't get much support from other nations, for sure. So when it comes to technologies, the payloads, all of them are new, and the niche technologies, all of them are developed indigenously. But yes, from time to time there are collaborative payloads, like in case of Chandrayaan 1 and Chandrayaan 2 and 3, there are some payloads from other nations as well. Right.
Somebody asks, how can biotechnology help in developing life support systems for astronauts in the future lunar missions?
In the future, okay. See, biotech becomes a very important part here. Why? Because in biotech, there are two aspects here. One, like biotechnology from a point of view of medicine, and biotechnology from a point of fundamental understanding of how microgravity, or let's say microgravity means lesser gravity, and radiation, like moon doesn't have an atmosphere, so radiation exposure is a lot. In fact, radiation exposure was one of the main reasons that after Apollo 15, there was no more Apollo missions. Okay, so to understand the effects of these radiation exposure and microgravity or reduced gravity on the moon on astronaut health is important, and accordingly, like such kind of medications can be given to them, or they can like understand that what medication or like kind of counter they can do to reduce such kind of bad health effects of such like prolonged stay on the moon. Second is from for biotechnology. When you're talking about life support system, biotechnology offers for various like space food related solutions, or that can like with that can provide for food with elongated lives is shelf life, and then biotechnology can offer for medical supplies or medical solutions that can be made in situ on the moon. So all of these solutions together can offer for a multifaceted solution for better living for any astronaut for a prolonged time on the moon. Okay, so space biotechnology, in fact, is a very um, like like um, booming field. If you see the current mission of Shubhanshu Shukla to the International Space Station, 6 experiments included, I think the five or four of them were just of space biotechnology. Okay, so you can understand that how important it is when it comes to prolonged mission, because biology shows its effect for over a prolonged time or an extended time. That's why if we go for prolonged period of time of study, we can get better understanding and at the same time produce in situ facility needs and all, like medicines or food and all, using space biotechnology. Okay, so these are some of the overview thoughts that I have for space biotech regarding your question. Yeah, any more questions?
You are muted. Just unmute yourself. Yes.
Oh, I was muted. I'll ask. I'll say the question again. Sujan asks, how did India manage to succeed in its space missions even with a low budget compared to other nations? This, yeah, an economic question somewhat.
Okay. As they say that necessity is the mother of invention, right? For us as a country with the modest of resources, what we have is aspirations and dreams that we never have curbed, or let's say have never shied away from to achieve. So when it comes to India, India doesn't have any choice. It has to work on a budget. Okay, so like when there are limits to it, even within those limits you can perform the best. But then when you have things in excess, in that also you can perform the best. But then that time you do not have that thing as, let's say, that you have a limit and you have to work on that. So it's kind of a necessity that India has to produce such great results at on a budget. Okay, so that is what I think so. Like when it comes to India's space exploration at a modest budget, but then with utmost scientific and engineering quality.
Nice, nice. So Magpreet has a kind of a career-related question. What can be the next step to join for space missions after MSc in space physics?
Could you please pardon? What can be the next step
For space missions after MSc in space physics? She's doing somewhat MSc.
You mean like after masters in space physics, what you can go forward with, right? If I'm not
Yeah.
wrong.
Yes, that.
See, means I'm a chemistry person. Okay, so when it comes to physics or maths or engineering, I often say that for you all, space, any field is open technically. After space physics, you can go for, let's say, satellite applications, or even you can go for atmospheric studies as well, or even you can go for um, like radiobiology as well, like when it comes to space physics, because a lot of radiation studies are based on space physics only. So you can go to become a scientist. You can go ahead to pursue something in engineering lines as well. Okay, and be it academic or even in startups, that are working on rockets or satellites or propulsion systems in India, there are job opportunities that you can go for, or even start your own company. Why not?
Yeah, that's nice. So, Huda has another question. What are some research gaps when it comes to lunar studies that we know of?
See, as such, when it comes to such kind of question, it is very difficult because when you're talking about research gaps, you have to do literature survey. Okay, so that is there. But then the moon has not been explored a lot. Something that I can say upfront now is the darker side, like the side of the moon that is not visible to us or from Earth. So that part of the moon is obviously something not that well explored yet. So maybe exploring that part of the moon would be nice. But then often when it comes to gap, like in research and with specific and specifically with regard to space, you have to see what technology is available with your country or your PhD guide or your research guide, and what data you have, what skills you have to analyze, and then comes the research gap. Okay, because it's not a lab experiment that you can set up and you can do it on your own. You have to rely on a like space mission or a spacecraft collecting data. You have to rely on the skill set that you have developed on your own, and then you can go on to solve a problem. Okay, so the problem or the gap should be feasible enough to solve. Okay, and like it should be something that can have a proximate answer. Okay.
Hmm. Nice. Dr. Arun asks, what are the scope of or space medicine in India? What about research in space medicine in India? What are the some space research associations that are related to medicine? He is
Okay.
a very medicine related person.
Right. Right. Thank you for the question because this is something that we also work on. For space medicine, like there are certain organizations, like for the government, you can always consider the Institute of Aerospace Medicine in Bengaluru. There are certain seats for that is specifically for like physicians, not for pharmacy or biotech individuals. If you are like into you have like finished your master like you have finished your medicine degree, bachelor's degree, and done an MD, like Doctor of Medicine, then you can go on to take a residency program or other at the Indian Institute of, sorry, I mean, Institute of Aerospace Medicine in Bangalore. That is one. You can also find some opportunities in um, the Human Space Flight Center, HSFC in Bangalore, and but then it is relatively less because the things have just started, and they often prefer taking people into space medicine via the Institute of Aerospace Medicine. And then, if you want to involve in research or educational activities, you can always come to Life and Beyond Foundation. We are associated with educational activities and also some parts of research, like in space pharmacy and space biology. Through the Tsiolkovsky Space Life Science Working Group, we publish on a regular basis. So these are some of the options, and uh, the main thing is when it comes to space medicine is that um, you have to specialize in medicine firstly, and or let's say if you are considering allied medicine fields in biotech or pharmacy, you can do that as well. And then when you go to into your doctoral program, you have to find a guide or someone or project group where you can work on these fields. Okay, it is growing. I would not say it is perfect enough or as booming as in US, but then there are certain level of like at the basic level there is some scope for space medicine in India. Yes.
Nice, nice. So, uh, majority of the questions have been answered. This was a very insightful session. According to the time constraints, we'll keep it a bit shorter than usual. What we'll do is, if you have any questions, please do mail us. I will give you our mail, propagation.connect@gmail.in. We'll answer all your questions. Any doubts, any career-related counseling, we'll help you out. All right. Now, apart from this session being very awesome and I'm learning a bunch of stuff for first time, me being the tech guy, I learned a lot about space and all that stuff. So I would really like to thank sir. Apart from me butchering his surname, I would really like to
No, no, it's
apologize.
okay.
Yeah. So I would like to apologize and would like to thank sir for his esteemed operations in here. I would now like to call upon my co-founder Jitendra. He would like to tell you more about the winter school, the future prospects that we'll have for you. It will be a very insightful session. There'll be a bunch of instructors. You'll have a personal counseling session. You'll have personal mentors. So I would now like to call upon him to introduce you to the winter school that we are trying to launch today. Now, Jitin, can we have you?
Yeah, hello everyone. How are you? Just raise your hand if you like the session today. Just raise your hand, everyone. Okay. So it seems like the session was really nice. Okay. That was nice. Okay. So as you all people already have been know, the people who are not familiar with the 23rd of August. So I think sir have been explained everything about the Chandrayaan mission and the future prospect of the ISRO also, like how they are just planning for the Chandrayaan 4 and 5 minutes run also. So after considering all those things, we just decided to celebrate this day. And with that, today we are just going to launch our next program called the Winter School of Astronomy and Astrophysics. That would be going for the complete 6 week of program, and which would be going to lead by the tutors, which are way more better in that in their own fields into the astronomy and astrophysics. And we have an expert panel member also, so you can just check out from our website. So let me just show you what are the things would be there into the complete 6 week of program. That is basically going to extend for the 8 weeks, because we are targeting for the people who are interested in astronomy and the astrophysics. With that, they just want to do the other parts, if they would just want to write any research paper or any projects, maybe it could be a computational one or the non-computational also, or any review paper also. So we are targeting those people. Okay, whether you are a school student, if you are in your high school, or if you are in your bachelor or in masters. So we are targeting for the people who are in school, in their high school and the bachelor and first year master's student. Those people can register for this program, and this would be for the 6 week of program, which is just going to extend for the 8 week also. Okay, and these are the curriculum. I'm just going to send this link of this page. Just go and check out by yourself only. And it's in this program, we are just going to basically in this school, we are just going to cover everything. Okay, about the astronomy, astrophysics, from the basic to advanced. Okay, but the very interesting part of this whole school would be the 6 week of that program. What would be that basically? In this week, we'll be going to guide you, and basically we'll be going to assign a guide for you also individually for everyone to write any research paper, review paper, or for doing any projects also. So this is I think the very exciting part of this program. I just hope that you people just go and check out by yourself only. So I just request to the team, just send them the link of this winter school. Just go and check out that, everyone. Okay. So if anyone having any doubt regarding this, just ask me right now. And now I'm just going to introduce myself. Hello everyone, this is Jitendra Yadav, founder of Propagation. With that, I'm a space science educator and the tutor at different places I've been worked. But yeah, currently I'm working in the Propagation. So if anyone having any doubts regarding the winter school or anything, you can just turn on your mic and ask me right now. Yeah, you'd be able to do that, Ayush, because we are just going to basically assign a guide for you. So that would be going to be helpful for you. So can student who have already completed their masters? Yeah, if you are interested in astronomy or astrophysics, definitely you can apply for that. Because this program is just going to for those people who doesn't know anything and who are just going to be intermediate of that. Okay. Do anyone having any other doubt? What is the last date to join that? Preet, yeah, we do not have decided the last date, but yeah, it would be going to be for the limited seat. So that would be the simple. Because if we are just planning to assign the personal guide for everyone, so we need to have the lesser seat. So that's why we have been basically designed this for the 100 people only. So
Yeah. They're very specific seats, only 100 people. So, and a bunch of them filled up. So,
if anyone having any other doubt, just turn on your mic and ask me writing, or just type in the chat box. Okay. I hope these things have been like clear. Will you guide us in our research paper? Uh, Not only me, but yeah, we have a team. So yeah, everyone will be there.
nice.
Okay.
Nice. I think this marks
Priyansu
the.
is saying like, can I write articles? Yeah, write a article is a like good thing. You can do that.
If you wish to
Basically,
write blogs, anything, you can write
basically,
them.
yeah. If you are interested in writing blog also, just write for the like propagation also. We have that post. Just mail us and we'll add you the team. So you'll be able to do that. How will we get the topic? Can we choose by your? There is two options. We have been designed like some of the number of projects. You can choose by from that also. And if you are interested in any such particular like topic, so you can choose that one also. We'll be going to guide. Is there any doubt from anyone? If anyone having any doubt, just type in the chat box, or you can just turn on your mic also. So you are all free to do that. Free to ask anything, everyone. Okay, I think no one is having any doubt. So yeah, of different university.
Guides will be professionals. There'll be a bunch of tutors that you'll be having.
Yeah,
Uh,
basically, as I told you, just go and check out the propagation website. You'll be able to find like we have the lots of expert panel members. But with that, we have been collaborated with around like 14 universities. You'll be going to get the like list of them, of the professor also. Yeah, that will be all.
but I'm a B
But
Pharma
I'm in
years.
the B Pharma second year student. So yeah, you can do that. Just think like if you are interested in space science, so these things are not going to matter. We'll be going to, we have been designing the curriculum like that only. If you are interested in the space science, so yeah, that's for you. Yeah,
Computer now must
Susan, there is like very little like things are important, but yeah, that is also we have been covered in that winter school only. So
It's not a.
everyone, if you having any doubt regarding the like winter school, so just let me tell you, like it is all about the astronomy, astrophysics, cosmology with computational part also. Like if someone is interested into the like computational project, so we are just going to like make them understand that also. Don't worry. Everyone, I think it's all done now. We have been send you the link, and if you're interested, we are just going to mail you that also. Just go and check out that, and just go and enroll in that. It would be for the like 2.5 month of program, because we all know like astronomy and astrophysics thing are way more basically a vast thing. So we need some time from you people also. So that would be of around like maybe 2.5 month of program. That is the thing. Okay, everyone. So, okay.
Nice. I'll mark the ends. I'll mark the ends of the session. Thank you so much, sir, for coming here, for educating everybody. We are marking the ends of today's session. If you have any questions, please do mail us. And the last of the instructions here are you'll have to fill a feedback form to get your certificates if you wish to get one. The feedback forms link will be sent out to you directly on your mails, or you can just go to the site where you registered and fill the feedback form. You'll have a button right there. You will see your feedback form after you register, after you have already registered and you fill the feedback form. After 24 hours, you'll see your certificate. All right. I hope everybody is satisfied with the answers to your questions. We will mark the end of
Yes, sir. Yes.
what? Okay, somebody said something, but yes. Okay, we'll mark the ends. Thank you, everybody. See you in winter school. We will end the session here. Thank you, sir. Thank you so much, everybody, for coming here.
Thank you, everyone.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you so much.
Thank you, sir. Thank you, sir, a lot for giving your
Thank you,
information.
sir.
Thank you. A lot of thank you.
Thank you, sir.
Everyone just turn on your camera. Just turn on your camera, everyone. So we could take, like, we could capture this moment.
Okay, sir.
Everyone just turn on your camera.
I'll take a quick selfie sort of stuff. Okay, we have it. Thank you, everybody. I'll end the calls. Bye, everybody.
Thank you, everyone.
Good night. Good night.
Yes.
मेरा प्लान बना लिया स्टोरी ही देना नहीं तो अदरवाइज तुमको वो